And welcome to the CVP webinar for our Hopper service offering. So Hopper is our managed DevSecOps platform. It is our software factory in a box, and we're actually going to run through a live demonstration. But first, let's go through some intros. So who are we? Why are we here? So my name is Fakir Ahmed. I am an executive director with CVP, Customer Value Partners, and I run our technology modernization practice. I focus on all things enterprise architecture, solution architecture, app dev, containers, Kubernetes, cloud, making sure that we're sourcing the right candidates for our teams, helping with business development activities, building solutions like Hopper that help accelerate our clients' needs. And I'll hand it over to Kevin to give an introduction.
Yeah, thanks, Fakir. I'm Kevin Raymond. I'm a lead technologist here at CVP. I pretty much do everything. I'm a generalist now these days. I do DevSecOps, cloud native infrastructure automation. I get into software engineering, even virtual augmented reality. I'm really just pushing, inside CVP and at our clients to adopt open source and just make life easier for everybody overall as much as possible.
Awesome. Thank you, Kevin. So we're going to kickstart our live demo now. Since it is an infrastructure demo, it does build and deploy things on AWS, and we'll go through the details of what that is. Kevin's going to kickstart. It does take about 40 to 45 minutes. So on the screen, you can see our service catalog solution where we launch all of our components and products and solutions. I'll hand it over to Kevin to launch Hopper right now, and then we'll go through all the intricacies of it.
Great, thanks. Yeah, this takes about 40 to 45 minutes, and we are going to roll the dice with a live demo. So everyone knows how that goes, and so we'll see how it goes here. Basically, our service catalog here is Coder. It's a continuous outcome delivery range, and we use it to accelerate deployment of any number of packages that we can create. So in this case, Hopper, we will deploy this. The goal, one of the goals with Coder is to minimize the amount of input and effort that it takes to deploy things. So while OpenShift, which is what Hopper uses, is a large and complex piece of software, we only require 6 pieces of information to deploy it. So let me finish pasting these in quickly. All right, so we will deploy this and we'll start seeing the OpenShift installation here, and the screen will log here in the background as Fakir continues on with the webinar, and that will shoot over when anything interesting happens.
Awesome, thank you. Maybe you want to just show real quick the empty AWS account. Just
oh yes, thank you. So here's the AWS account we'll be deploying to.
Hand.
And no instances running right now. So after this deploys a little bit here, we'll go ahead and refresh this and we'll just see some of the instances popping up. It actually deploys into a brand new VPC and everything else related. So we'll take a look at that.
Thanks, Kevin. And we'll get into more technical details throughout the presentation. So first of all, a little bit about CVP, Customer Value Partners. We are a consulting firm, an advanced technology services firm, but really the way we like to really approach problems is we are helping our clients navigate change. We know more than ever, technology is moving at such an accelerated pace these days that the things we build today are no longer going to be relevant or useful in 12 to 18 months from now. So the things we're always building, we know there's always going to be some rework, and how do we help our clients navigate through that change with not just technology, but societal changes? How do we help them deal with their mission goals, mission statements changing? And that's really where, although we're all technologists at heart, we wrap all of our engagements with that type of thought leadership. So CVP has been around for more than 17 years. We are largely focused in the DC, Maryland, Virginia area, where we did have a lot of on-site work in DC itself before COVID hit. We're now 100% remote. We do have big programs in Kansas City and in Denver, and we're about 500 employees today. And we align around a couple things. So vertically, we are aligned on our core markets in national security, government health, and civilian agencies. And then horizontally, our practices come in and infuse the best practices, solutions, standard operating procedures, recruiting, sourcing, and helping make sure all of our teams are delivering the highest quality technology products and solutions. So our practices, I run our technology modernization practice. We also have a healthcare consulting practice, which is healthcare SMEs, informaticists that focus on healthcare policy. We have a business transformation practice that focuses in on management consulting, organizational change management, user-centered design, customer experience. Data science and engineering practice that focuses in on big data, ETL projects, data analytics, and our cybersecurity project, which wraps everything we do. We are always focused on cybersecurity, how to make sure we're shifting left with all of our cybersecurity practices and automating those things with our CI/CD pipelines into products like Hopper. So what are the key challenges technology executives face today? So think the CIO shop or CTO shop and anyone responsible for any kind of application delivery, delivery at scale, or infrastructure teams, DevOps teams, cloud teams. So the first thing we've been seeing in federal agencies and really any large organization, even in the commercial space, is technology sprawl. We have lots of technology choices and options and different cloud providers and lots of different open source tools and COTS products. And if you're not standardizing or at least slimming down that pool of available technologies and useful technologies, you quickly get sprawl and things run out of control. One of our recent clients at a federal agency lamented to us and said, I have over 100 different agile teams building software in a different way. They're building and deploying to over 100 different endpoints. How do I possibly secure all that? How do I do an ATO? How do I scale my goals, my agency's goals, our mission goals, if I can't even get a handle on all that technology sprawl? How do I train my teams on those technologies? How do I build great software products and deliver value as quickly as possible? So these are some of the problems we're seeing. And also, how do I remove, as a CIO or CTO or technology executive, how do I get things deployed faster with better security? How do I remove those rigid manual steps, that friction in my process? I want things that are frictionless and easy. And how do I create portable workloads that could go to any cloud environment? How do I get away from costly COTS products and get more to open source? And how could I get to the pie in the sky goal of deploying to production safely multiple times a day, not just deploying to a dev, test, or stage environment, but actually get it to production and actually get it into end user hands, clients, customers' hands. So understanding those key challenges, we know technology executives have three big goals. How do I improve speed to market of my services, my products, my web applications, my sites, my mobile products, mobile applications, to help improve the lives of agencies, federal users, or, and more importantly, the citizens? And at the same time, while doing that, how do I reduce cost? And oh yeah, also improving quality and security at the same time. Really, really tall order, really difficult set of metrics that we need to hit and help our clients hit. And also, how, as a CIO or CTO, how do I do this with ever shrinking budgets year over year? And how do I do this when 70 to 80% of my current budgets are just going for O&M, just maintaining the lights, keeping the lights on, maintaining the old stuff, without even focusing in on the new cool stuff that'll actually help me scale and meet all my goals and solve all my key challenges. So that's where we developed our Hopper solution, an intelligent self-healing automated platform as a service. So before I get into what Hopper is, let me just spend a couple minutes talking about where we came up with the name. So for the past 14 months at CVP, we have been naming our solutions, our products, after famous women in STEM, science, technology, engineering, math. Famous women that had a really, really big impact on technology. And so we named Hopper after Grace Hopper. She was a rear admiral in the US Navy. She had to fight tooth and nail to get anything done to climb the ladder at the Navy. She was a female in a heavily male-oriented organization in the 40s and 50s. She was laughed out of every room when she made suggestions. One of her big suggestions in the early days was, hey, why are we using these esoteric terms and assembly language type programming? Why don't we use English words? It'll make it easier to program, debug, easier to teach. So eventually she came up with a couple programming languages, and then which led to the COBOL programming language that a bunch of folks have used. And she also coined the famous term debugging. So there was a very famous story where she was working on the big Mark II IBM system at Harvard University in the 50s, post-World War II for the Navy. And these are the days when computers took up entire rooms. And one day her team was trying to run a program and things were failing. So when they were trying to figure it out, they actually had to open up the pieces of the computer, actually look into the hardware, and they found a moth that was interrupting their programs. They took out the moth, and she coined the term debugging. And hence if you look at the Hopper graphic, the O is actually a moth. She's a pioneer of lots of programming languages, compilers, distributed networks, really, really amazing story. So I recommend everybody should learn her story. So that's where we came with the name. But what is Hopper? Hopper is our managed platform as a service. It provides a intelligent, self-healing, automated infrastructure that helps solve those key challenges, that helps meet those executive goals, allows us to standardize the way we build software. It allows us to make quick deployments to the cloud. It allows us to have really, really high quality, security, and scalability. And everything is automated as code.
Yeah, Fakir, real quick, I can
Yep.
jump in here and we can go take a look at the console real quick. Let me just maximize so we can zoom it in a bit here. So I'll just going to do a refresh here, and we'll see that here's 4 instances so far that have been created. The Bootstrap instance starts out the cluster. It's going to transfer ownership over to these master control plane instances and go on from there. So it has created everything VPC down, and we'll see some more of that after it's finished.
Awesome. All right. Let's see, there we go. Okay, perfect. All right, so this is our ConOps graphic of Hopper, our software delivery platform. As I envision it and call it, it's really a software factory in a box. So I always give the analogy of, say you're a car company and you have this great idea for a car, you want to build a car, you have the design, you spend a lot of money to build a prototype, and you really want to just get in the hands of customers and start selling it. And that's great, but you have to build it, you have to test it, and then you have to sell it at scale. So how do you do that? Well, you have to have all those pieces in place first to actually see that vision come to life. So that's what Hopper is. We set up and this, we're running through the infrastructure setup right now. So essentially we set up a software factory in a box. And what do you get? So first of all, we deploy, and this is all done in infrastructure as code, we deploy STIG hardened and CIS hardened virtual machines to any cloud provider, so AWS, Azure, Google, or any VMware based infrastructure. And right now we're doing the deployment to AWS. And on top of those STIG hardened virtual machines, we deploy a Kubernetes cluster. And for our Kubernetes example here, we're using OpenShift, which is from Red Hat, and that's the Cadillac of Kubernetes clusters, but you could always use vanilla open source Kubernetes, VMware Tanzu, Rancher Federal. You could use any of the managed service offerings from AWS, Azure, or Google, and all of those are interchangeable. So all the tools that we're going to mention here, they're all interchangeable, and they're very easily interchangeable because not only do we deploy them through our coder service catalog with a single button click, but it's all ultimately Terraform scripts, infrastructure as code behind the scenes. So that's always easier to edit and store and gets version controlled in a Git repository. So once you get the cluster, And we're going to see all of this live as it starts to become live on Kevin's screen. You also get a Jenkins CI/CD set of containers and dynamically allocated build container agents. You get a SonarQube container for static code analysis. You get a Splunk stood up as a container, so you could feed all your operational logs and see dashboards and integrate all of our data. And we'll see all of that as well. In a couple of weeks, you'll see an example of us deploying a few starter kits applications. So containerized applications like React, Node, Postgres, or React, Java, Postgres, or different permutations of that, .NET. And starter kit CI/CD pipelines that actually run through all the tools and give examples. So we're not just standing up all this infrastructure, but we're also giving examples of how it works. We're not just standing up this infrastructure as silo tools, they're all integrated and they all work seamlessly out of the box in 45 minutes. So we saw Coder, that's our service catalog of solutions. And we also provide 3 machine learning models that help improve developer productivity, quality, and security. And we always focus on cloud first, cloud native solutions. So what do you get with Hopper? So today versus tomorrow. So today, we know to set up something like this, to set up your software factory, any kind of factory, it's a very labor intensive setup. There's lots of tools. There's lots of security regulations you got to meet, and compliance regulations for different environments that you're deploying to. You need expertise in Splunk or OpenShift in the cloud. And while you could get all of these and they're not impossible to do, it does take a lot of time. And we accelerate that by providing this with our infrastructure as code setup, and you get this in minutes. Right now, you also have infrastructure drift, Snowflake configurations. With this, you get a very consistent, standardized way of setting up your tooling and setting up your application environments and coding, testing, and building and deploying. And it also sits on STIG-hardened CIS compliant infrastructure. New project delays. We know that there are a lot of steps that have to happen before you start a new project, before you get your environments, before you hit your first CI/CD pipelines. That's one of the main reasons we built Hopper, was not just to sell as a solution, but we were facing these same issues internally for every new project and for all of our tech challenges that we're doing for different procurement opportunities. And we just said, hey, why are we doing this over and over again? It's the same set of steps, the same set of tools. Let's just automate all this. Let's just make it really, really, really easy, stupid easy for anybody in our company to stand this up and stand it up for our clients. And then we said, hey, this is a good differentiator. This is a good accelerant for other clients. So let's take this to the market and let this be available to everybody. We also avoid vendor lock-in or single point solutions. As I mentioned before, everything's interchangeable. It's all infrastructure as code. We also provide SonarQube container scanning tools like Sysdig Falco out of the box. We also eliminate software delivery productivity waste. And we do this through our machine learning models, which we'll talk about in a little bit. They help improve security, quality, and productivity. And we try to get away from expensive on-prem solutions, again, going to the cloud. So at this point, I'm going to ask if there are any questions. Kevin, do you see? I have a couple questions.
Yeah, and if you just want to type your questions in, if you're not familiar, you can look at the Q&A window and type in a question if you have any so far.
Right. Oh, that's right. I forgot some announcements. Q&A. We are going to do questions now, and then also at the end. We will be sending out a short survey after the event, so we would love your feedback. And we are recording all of this, and it'll be on our landing page, our Hopper landing page on CVP Corp website. So in case you have to drop off, or you thought, hey, this is interesting, I want other people to see this, we can do that. So a couple questions. Let's see. On average, how much project startup time does CVP Hopper reduce? So great question. It is variable, depends on your organization and your implementation requirements. But we've seen if you want to stand all these up from scratch versus using this, it does save about 8 to 12 weeks because we usually have to get in, you have to get access, you have to install all the tools, integrate them, test them. And we're not even talking about the ATO process. One thing that we actually do offer is free ATO documentation for Hopper. So if you're deploying AWS or Azure or wherever, has to be ATO'd because you're a federal agency. We actually already produced the documentation for this where it inherits the controls from the cloud provider. And then we show for FedRAMP moderate or FedRAMP high requirements, all the controls that Hopper adheres to, and then any of the gaps that you as an agency have to fill in. Let's see, a couple other questions. What are some of your post-deployment automated testing tools? So actually, I'll talk about that in a second because we're going to get there. And how do existing clients use this? So I'm actually going to hold off on that question as well because I want to get through the rest of this presentation. And Kevin, were there any other questions that let's see?
I do not see any others coming in at this point. So.
All right. Well, I'll hold off on those and we'll get to them. All right. So, reference architecture. Why are we showing this? So, our philosophy at CVP is to build loosely coupled cloud native microservice based architectures, portable using Docker containers. And why do we do this? Well, we like the scalability of the cloud. We like being cloud native. We like portability. We like open source. We really, really like to give our clients, just as we do internally with our own stuff, lots of options and flexibility. So looking at this reference architecture, starting at the bottom, we always utilize a cloud service provider. We ideally want that, AWS, Azure, Google Cloud. We have partnerships with all these cloud providers. We use Kubernetes as our container orchestration platform. And in this case, for this demo, we're using OpenShift. As I mentioned before, we have other Kubernetes distributions we could use. Then we have data services, business services, and applications. Our business services are the traditional containerized microservices or APIs that you think of, reusable services. Data services could be in containers or utilizing the managed service offerings for databases like RDS in AWS. And then our applications, we tend to use JavaScript-based front-end tools for our applications. Static code, meaning containerized Vue, React, or Angular applications, and using 508 compliant US digital web standards for our front ends. And bookending our security and operations, security scanning, shifting left security by training our developers on OWASP top 10 or security coding best practices, and then implementing security scanning in the pipelines, our build pipelines. We're actually going to demo that in a couple of weeks on February 5th. We hope everybody joins that. And then our operations. From an operations point of view, especially observability and alerting, things we do for monitoring, tracing, logging, and visualizations in dashboards. And we're going to show Splunk as our dashboard tool, but we also have other open source options like Grafana. All right, cool. Our infrastructure, and this is where I could actually answer one of the questions for post-deployment steps. So we believe not only in infrastructure as code, we believe in everything as code philosophy here at CVP. So it's not just your applications or your infrastructure, but it's also your pipelines. It's your Kubernetes declarative configurations. It is your security policies as code. Everything is as code. And in a couple of weeks, we'll show how we spin up automated, dynamically created CI/CD CS pipelines. So continuous integration, continuous delivery, continuous security, automated build, test, deployment pipeline. So running through this example pipeline, we integrate with any kind of Git repository, GitHub, GitLab, Bitbucket are the big ones that our clients are using these days. We do static code analysis using SonarQube, which is out of the box integrated. HP Fortify, we could add in if you have that tool already licensed. Based on your tech stack, there are different build tools, Maven and for Java, MS Build for .NET, NPM if you're just assembling or transpiling JavaScript components. And then we do automated tests, NUnit, JUnit, Mocha, Jasmine, Karma for front end applications, for middle tier, and even for database components. And then we do vulnerability tests with tools like Sneak. And then we containerize, we do Docker containers, make sure we version, tag, push it to different registries, different registry options with the cloud providers themselves or Kubernetes distributions like OpenShift. Then we deploy their applications to a Kubernetes cluster. And then post-deployment, dev test stage, even production, we could run automated UI feature tests with tools like Selenium or Cypress, and then do automated penetration tests with tools like OWASP, ZAP. And all of this is defined, versioned, and managed in code in a Git repo. So let's talk about the intelligence piece for Hopper. This is the machine learning model bundle. This is where we actually have another solution called Nightingale, a data science solution, where we worked with our data science team and we built these models. So the first one is called our developer productivity model. So this is a model where we integrate into Jira to help with estimation, sprint planning, essentially. We all know that when we start a new project, new team, or we have an existing team, we're adding a new big feature or framework or ways that just don't allow us to have really good sprint planning. We know it takes a few sprints to kind of get it to a steady state. So what we've done here to accelerate that is we look at 3 to 5 years worth of Jira data or project data, where we look at all the stories, all the previous estimates your team has done versus the estimates that it actually turned out to be. We trained a model and where we could actually integrate with Jira. We call it our Hopper bot Jira integration. And what it does is as soon as you're doing sprint planning, as soon as you enter a new feature with a story point estimation, as soon as you enter it and hit create, the Hopper bot instantly takes that story, runs it through our model, and then gives a comment in that same Jira story. Yes, your story points are accurate, or no, I recommend instead of 5 story points, it should be 3 story points. Our quality model is also utilizing our Hopperbot Jira integration, but in this case, it's for bugs, defects. So anytime you have defects, especially in production or tests, you have to go through a triage process. And that triage, apologize, that some of our dogs in the background. So there's always a triage process where you have to figure out, okay, there's this bug, who fixes it? What component is it in? What's the, which source code files do they need to look at? How do I reproduce this? So instead of going through that front end process, we want to automate all that. Wouldn't it be great if you just create a bug and all of that is already pre-populated for you automatically? So again, we used our Nightingale data science tool and we trained a model that looked at 3 to 5 years of historic data, again, of bugs. And then based on that, we could train this for any team, for any client. Anytime you enter a quality issue or a bug, the Hopperbot model will be run. Hopperbot will run it against that model and automatically add an entry in Jira to tell you, hey, this is the developer that should fix it. These are the source code files. This is essentially the component, and off you go. And on the security model, this is an untrained model where it essentially looks at access logs, operational logs, and tells you if there's abnormal usage, and then identifies that and alerts your CISO or ops teams. This is our Hopper service catalog. We saw a demo of this in the beginning. Kevin kicked off the Hopper deployment from there. One thing I want to point out here, we have lots of solutions. We also have individual components. You could configure these in our tool and you provision them to AWS, Azure, Google, or VMware-based data center infrastructures. Again, all of these are just infrastructure as code behind the scenes, so you don't even need our tool. You could just take our infrastructure as code scripts or deployment installation scripts. These are all version controlled in Git, so you could always customize for your needs. So what are some big differentiators and benefits of Hopper? So first of all, you get that standardized DevSecOps platform, right? That allows you to have scalability, speed, allows you to consolidate all your tooling. In that example where I gave with the 100 deployment systems, 100 teams, they could drastically reduce all the tooling that they use today, or move more to open source to get rid of expensive vendor COTS tools. Pre-integrated starter kit components and application frameworks. That's our coder service catalog again. Acceleration, speed to market. Again, this allows you to kickstart your projects. Hey, I have a Java project. Well, let me deploy Hopper infrastructure. Let me get a Java starter kit. Let me get some sample CI/CD pipelines that shows me how to use Kubernetes, that shows me how to have a containerized infrastructure, that shows me how to use a standardized way of building, testing, and deploying. Now I could build on that. Now I could train all my teams on that. Now I could scale everybody. Intelligence. We saw the machine learning models, and Kubernetes is out of the box self-healing infrastructure. What does that mean? Well, Kubernetes utilizes a declarative configuration model. So declarative meaning code, infrastructure is code. You define your infrastructure setup for Kubernetes. This is the number of nodes in my cluster. Pods is where I want to deploy containers. It automatically deploys containers wherever based on resource allocation needs. But more importantly, it tells you, hey, these are the VMs, this is the compute. This is the setup of my application. And if anything happens to that, as we know, issues happen in the cloud or servers, or if somebody logs in manually and mucks with anything, Kubernetes will always revert back to that configuration. So it's always scanning. If anything happens, it's either go to kill pods, kill containers, spin stuff up, or revert the configuration back to its natural state, which is awesome. Cost containment, everything just works out of the box. As we're seeing here, 45 minutes, and you get the machine learning models, no additional cost. And security tools. So STIG-hardened infrastructure, we use Packer for our infrastructure as code for creating those STIG virtual machines. And again, those are customizable for agencies' needs. Every agency might have a different need. Or if you already have golden images in your data centers or your cloud providers, we could definitely use and build and deploy on top of those. And all the security tools integrated out of the box for your pipelines. So we talked about SonarQube, and Splunk, and Sysdig Falco, and Sneak, and lots of other things, and all feed to Splunk. So what are some of the deployment options? There are three main deployment options. So let's start on the bottom right. First of all, we could deploy this on-prem. We could deploy this to your VMware-based infrastructure. We prefer not. We prefer the cloud just for its flexibility, elasticity, and cloud-native services. So bottom left, we could deploy to any cloud client environment. So as Kevin showed you in the coder catalog, you just have to enter 6 pieces of data and open up access to AWS, Google, or Azure, and we could deploy there. Or we could create a sub-account off of our main CVP AWS account and give you full 100% access and control. You could spin up Hopper or Nightingale, any of our solutions in our service catalog, and you get a sandbox to play with. That could be your dev test environment, or even could be your production environment. We could ATO that, and we could make it 100% owned by you, a federal agency or commercial client. So this is the Hopper reference architecture. This is what's being spun up today. Everything is as code, Git. In our case, we use GitLab internally. As I mentioned, Packer scripts to create our STIG-hardened CIS validated virtual machines. In this case, EC2 instances in AWS. OpenShift, as I mentioned, deployed to our STIG-hardened virtual machines. All of our Docker files have been scanned and hardened for security before being deployed. Jenkins is deployed as the Jenkins CI/CD master is deployed as a container. And then every pipeline is dynamically spun up and configured with all the plugins and tools needed to be the build agents. We use an open source tool called Jaeger for distributed tracing. That's also deployed as a container. Jaeger is good for microservice debugging as we now move to more distributed microservice loosely coupled architectures, which is great. It does make it a little bit more complex to deploy, makes it a little more complex to observe, more complex to debug. So Jaeger helps with that, where it shows all the different calls to all the different containers and APIs, and puts it together into nice dashboards so you could help and see the whole call stack for every call trace for every API. SonarQube deployed as a container for static code analysis. We'll see that in action in a couple of weeks, although we will log into the console here. Splunk, same thing, deployed as a container for log monitoring. All the data is fed there, and that's where we could train our ML models. Sysdig Falco is deployed as a runtime threat detection as a container as well. So essentially think of Sysdig Falco as your Norton antivirus or McAfee or something that runs and scans and is looking at all your containers to make sure that there's no funny business, there's no hacking, no security holes. Or also we could configure policies, security policies. If there's something agency specific on how you want your containers to run, we could also plug that into Falco. And then one thing I want to mention about Splunk, if you don't have a license, we could swap that out with Prometheus in Grafana for log monitoring and also dashboarding. And it looks like something's happening. And before we hand it off to questions, I'll hand it off to Kevin for a second.
Yeah, good timing. So right now at this point, the cluster itself has been created. At the end of the deployment, there's a nice summary of all the information, but I'm just going to pull it out of the middle here so we can take a quick look at what has been created so far. And the alert warnings that were displayed are just because this is using some self-signed certificates. So here it is. Let me do this real quick. Here is our OpenShift Hopper deployment. So it's still spinning up all of the apps, Splunk, Jenkins, SonarQube. We can go ahead and take a look at what is happening. Here it's just showing in our Hopper namespace each of the pods that's being spun up. So actually right now the SonarQube is already prepared. This gives us a route to it. Don't know if I can get the password, but we're going to leave it right here for a minute on the login screen. So as this stuff spins up, more visual feedback will occur here. We can look at a little bit more details of the project itself. It's starting to show utilization of the different resources, and this will keep track of everything. The inventory of all the Kubernetes components that are being deployed as part of the Hopper installation. This one will show each of the pods as it's coming up. We just see the Splunk operator pod just popped up. That's actually operators are a pretty cool new thing. They basically codify a site reliability engineer in SRE. So as this spins up, then this pod itself, the operator, will create our Splunk instances for us. So we will see those here in a few minutes. And yep, so it's already started and we're giving it a little time to wait. Let me see if I can make this bigger here. There we go. So let me just go ahead and put this back down here for now.
Yeah, I
while
could
we
run
wait.
through some questions and Q&A and hand it back to you, Kevin.
Yep.
All right, so let's check some of the questions. All right. How do existing clients use this? I think there was an earlier question. I wanted to wait till the end. So great question. First of all, we do know some clients, a lot of clients actually, are already on their journey to the cloud, multi-cloud, open source, containers, Kubernetes. We know that that journey has already started, right? It's not a one size fits all for Hopper, and we don't have to rip and replace everything or ask you to start from scratch, although that is always nice, but that's not realistic. We understand that. But the nice thing is this is all infrastructure as code. All of our tools are interchangeable. We have all the components. This is a great end state we want to bring clients to, but we know that there's a journey. So what we do for our engagements is we do a health assessment where we go in and we scan your environment. We understand the as is state and compare it to the to be state. We provide a gap analysis and help you with a roadmap, and then actually start to piecemeal and help you get to that end state. And we could take Hopper as is, or we could customize it for you. We could take components of it. If you don't use Jenkins, you want Travis CI, or if you're in Google Cloud, we could help you in Google Cloud. But the main thing is it's not a big bang, never-ending initiative where we have this big great idea and we never get there. We actually break it down into bite-sized components, into PIs, and make sure we we get things done every quarter. We actually have a 2-week Kickstarter for Hopper. So Kevin and I and his team would go in and start to understand your infrastructure, and we could deploy Hopper immediately, and then start to provide access and create sandbox projects for your teams to start playing around with the starter kit components, the starter kit applications, sample pipelines, and then we could analyze your as is state, and then, like I said before, start to get you to that end goal. So how do you deal with siloed teams? So development, IV&V, operations. So great question. We do understand that not all development teams, like say in our cutting edge industry organizations like Amazon, Netflix, Twitter, any of these internet scale companies, or even smaller companies or agencies like USCIS or CMS, not all of them are set up where the dev team owns everything from feature, build, test, deploy to production. I own that microservice. I own that application in production. I, as a developer, am responsible for that. We understand there are silos, and we are seeing actually there is a strong culture of change management where we're actually seeing our clients move to more of a domain-driven architecture and domain-oriented setup. So we could help them build reusable web services, tools, and components that are actually abstracted away from the technology plumbing, which allows those domains and teams to scale. So let me actually answer the real question. So how do we deal with that? Well, like I said before, we're able to bring in Hopper to bridge those gaps. So the different configurations and different tools could help each of those different silos. Ideally, we'd like to help your organization change to more of a domain-oriented, domain-driven infrastructure and organization, but Hopper is flexible enough where we can actually plug and play to any environment. Let's see. I don't have access to Jira. How could I use the machine learning models? Okay, great question. So as I understand this question is, let's say I'm a customer. I like your Hopper.Jira integration or the sound of that or the idea of that, but I don't have access to Jira. I can't do anything. It's just a SaaS tool, essentially. Or maybe I use the SaaS cloud from Atlassian. So the nice thing is we actually have a standalone tool where you could feed all the raw data for your developer productivity, quality, and logs as CSV files or log files, and then it essentially executes the models and gets the result. We use this as a test harness just to test our stuff, but we've hardened it and made it available to our clients. So even if you can't utilize our Hopperbot for Jira integration, you could still get the power of our models. And we also release new models every quarter for free to all of our clients. How could I use Hopper to control cloud spending? Another good question. So first of all, we use the Coder Service Catalog to deploy, manage, and tear down everything in a cloud infrastructure. So think about just a baseline infrastructure, your VPCs, your clusters, your applications, your frameworks, everything. We also have a feature in Coder where you could enter a budget for every team and get, and we have a management approval workflow. So you can't just willy-nilly deploy anything. And so the workflow works as you select what you want, and then you get a manager approval. And if it's within your budget, we'll deploy it. And then we have dashboards that show not only what you've deployed, but how much it's costing you in each of those clouds. And we notify you when you're at 70% of that spend. So there are guardrails to help ensure that you're not just deploying, 10,000 clusters of Hopper in day one. Kevin, looks like some good stuff is happening on your side.
Yeah, thanks. So we have finished the deployment. As you can see here, the summary of installation information. I sort of cheated along the way, but this gives you, for this particular deployment, the Jenkins, SonarQube, and Splunk, and the OpenShift console URLs and administrative credentials, so we can sign in. If we look back into OpenShift, we'll see the pods are all deployed. You can even see an example here. This red one is having an error right now, so it's showing us it's having a crash. So what we're going to see here in a second is it will terminate itself. and it will try to restart, and it's just going to keep doing this. This particular error is a bug that's in the console, but it's good for an example. Some of the, if we look back over at the pods here, we can see a more tabular overview. So we have our Jenkins operator, which has deployed our Jenkins master instance. We look at that. That's deployed using OAuth integration with OpenShift credentials. So it's a single sign-on, basically. And we can get into the Jenkins master. Now, as Firkir mentioned, we will be having a demonstration of actually how a sample application fits through all this in a couple weeks. So right now, this is just the empty Jenkins master. If we go back, we can see Sonar Cubes here. It's even deployed a PostgreSQL database also within the cluster. And from Sonar Cube, the same thing. Once we have that sample app going through the pipeline, all of the Sonar Cube static analysis will be available here to look at. The final big deployment of this is the Splunk standalone pod. That's the one we feed all of our information to. Oops, this tab. So actually, I had put this page on auto refresh. It takes 2 or 3 minutes usually for logs to start being ingested and picked up. So we can see all the pods and nodes currently being monitored through Splunk. So if we could pick just one, this is the kind of information that's readily available in Splunk. You just get to see, in this case, resource usage and summaries. As more data is, ingested, these charts will feed into deeper analysis that's possible to compare things. Other events can be pulled in. It's pretty much whatever is needed for the specific deployment. Splunk is a big product. It costs a lot of money. So if Splunk is not something that is amicable to your budget, we also have the Prometheus and Grafana monitoring is built into the deployment as well. And this is just included here by default. And it's basically the same information, just it will take a little bit more work to get to see all of it. But we can look at dashboards, we can see metrics, excuse me, different alerts and events that happen across the cluster, and you can drill down into pods and different things like that. So going back to the administrator view real quick, gives us an overview of the entire cluster. And we can even see this is cluster-wide resource utilization, how much resources are made from the pool of EC2 instances that have been created, and all the other Kubernetes administrative features that you can ever want to do. It's pretty good. There's, let's see, there's one more thing. As we get into the next webinar, we'll be able to show how the build pipelines work here, and this will all be packaged up. We wanted to save that for the next webinar to just focus here on the initial infrastructure deployment. But basically, the sample app will live here, and there'll be pipelines configured, and you will see everything from a source code check-in to successful deployment here within the cluster.
Yeah, so I could jump in for a second.
Yeah,
First
totally.
of all, amicable to your wallet. I like that. I'm going to use that next time I go buy a car.
Nice.
But a couple other things. As you saw this being spun up live, it's real, and Kevin is logging into the different tools. If you go back to Coder, there are passwords. I just want to point out that those are dynamically generated. Those are not static passwords. They're not like the standard admin, and things could get hacked. So these are dynamically created, and we can even get tighter security with key managers and key stores. But out of the box, that's the setup.
Right,
and I do want to also mention, and yeah, I'll hand it over to you in a sec, Kevin, to talk about that. But Splunk is a great tool. It is expensive, and it's a beast. I mean, to get it deployed and integrated with feeds like this and getting dashboards right out of the box in 45 minutes, to me, that's pretty cool, because it is not an easy tool to set up and use. So While we do invest in this, like I said before, or like Kevin mentioned, Prometheus and Grafana are a nice open source alternative. They're packaged with OpenShift, so that's great. But even if you don't use OpenShift, they're CNCF certified open source tools, Cloud Native Compute Foundation, and we make those available in your Hopper configuration setup.
Right. So also, in addition to the passwords, the cluster ID itself is also randomly generated. So the domain that you provide is that root domain, which was this right here. It builds everything off of that root domain. In this case, since it's in AWS, it's using Route 53, and it configures all of the DNS entries automatically. Then let's see. So this was just to show in Splunk, just since we've started this up, we have got 266,000 events recorded since the ingestion of the logs began. So just over a few hours, I think another time there was over, I don't remember, it was like 3 million events or something were already recorded. So tons of data pulled in for analysis. This free version of Splunk that we use to demonstrate only lets you store 500 gigabytes, which if you know log files, you can fill that up in about 5 minutes. So definitely using the internal tools is a good viable option, and any other monitoring tools also, and like all the other parts of this demonstration are interchangeable. You know, as we keep saying, we can swap out Jenkins for different CI/CD pipeline solutions. We can swap out the monitoring. We can swap out whatever tools are needed. You know, some might require some extra effort to fit into a container ecosystem, but pretty much everything can be configured to fit in here. So it's definitely a lot of flexibility.
Yeah, that's a good point. So definitely want to make sure that that resonates with folks. You know, infrastructure as code, speed, acceleration, flexibility, customization, everything stored in a Git repository. These are things we live by at CVP, our philosophies, the way we implement all of our projects. So it's been really fun to see that actually come to life here, and fun to see it actually get into the hands of our clients. So I see that we have no more questions. We're at the end of the deck. So Kevin, is there anything else that you want to show? Otherwise,
Yeah, real quick on the monitor. So good open monitoring really solves a lot of issues. You know, when your website goes down for days and you don't know because you only got one alert or stuff like that, or performance issues are causing problems. So this is just looking again at the options. I think monitoring is great. So this is Grafana, the UI, and this comes built in. So you can open this dashboard itself external to the cluster. I mean, it pulls in the same data, but you can look at it directly in the Grafana UI. If that's better, you can have a little bit more flexibility as far as what your data, as far as your dashboards goes, configuration wise, what you want to see and sharing. So you can see there's just tons of stuff. It's real time, so we can watch it update live as it's coming in. And it's just, the sky's the limit when you get into monitoring, as far as the cluster down to the nodes, and then the pods and the containers, all the related services and other components. So definitely helps as far as visibility and keeping things running in the top shape.
awesome.
Yeah.
Awesome. Well, let me just make sure if we have any more questions. Doesn't look like it.
Nope.
So I think we're at the end of this webinar. And again, I just want to mention that we will be sending out a short survey, and we would love your feedback. And we hope you all join us in a couple weeks where we actually build on top of this webinar and we show some starter kit examples running through our pipelines, all again provisioned through our Coder service catalog. And those could be deployed not just to Hopper infrastructure, really to any Kubernetes cluster. So really excited about that.
Yeah, it should be really good.
And that's it. So thank you all for the time, and we'll be ending the webinar now. Thank you.
Thanks, everyone.